so today we're going to talk about the concept of mathematical expectation. Okay, so basically we're going to set up a probability distribution where we look at what is the probability for winning, what's the probability for losing, and how much do you gain or lose when you win or lose. Okay, and then what we can do is we can compare all of that and we can determine how much you can expect to win or lose each time you play a game. So this is what we call a probability distribution. This is what we call a probability distribution, okay, where we're going to look at all of the different ways we can win or lose and how much we can win or lose. So in this value row, you're going to put how much you're winning or losing. In the probability row, you're going to put the probability of winning or losing that. Then to calculate your mathematical expectation, okay, you're going to take the value times the probability, the value times the probability, the value times the probability, and add them together. And this is going to tell us how much we could expect to win or lose each time we play. All right, so you have these problems in front of you. Please read through example number 1. Roulette. This is a real thing here. Okay, so what's in our sample space? Sample space means what are the different things that can happen. We could land on a red, we could land on a black, or we could land on a green. Okay, now in this particular scenario, winning means we land on red because he bet $1 on red, right? Okay, so what is the probability of winning? How many different slots are there?
38.
38. And how many of them are red? 18. So we have an 18 out of 38 chance of winning. We lose if we don't hit red. So what is that probability? How many of them are not red? 20 out of 38. Okay? So we're going to create a probability distribution, okay, based on the fact that he is going to bet $1. Okay, so we're going to create a distribution. We have value and probability. Okay. So first of all, we could win. How much would we win? Okay, so he gains $1. He bets $1 and he gets back an extra $1. So he gains $1. And what's that probability? 18 out of 38. Okay. Or he could lose. How much money is he losing? So he's down $1. So we're going to put a -$1 because he lost $1. that probability is 20/38. So our mathematical expectation, we're going to multiply the value times the probability for each one and add them together. So our mathematical expectation would be +1 times 18/38 added to -1 times 18/38. What? Oh, sorry, 20. Thank you. Yeah, it's talking and I wasn't paying attention. Okay? So we just multiply our columns together and then add them. Can you come back in 10 minutes?
Yeah.
Thank you. Okay, so what is this? -2/38. Okay, what is that as a decimal? Okay, so if our mathematical expectation is this, what does that mean? We have a greater chance of losing. This is true. But basically this is saying each time we play, we can expect to lose 5 cents. Okay? On average. Okay? Now, are there going to be times that you win? Yes. Are there going to be times that you lose? Yes. But if you play this game over and over and over and over and over, you can expect to lose 5 cents each time. Which means if you play the game 100 times, how much can you expect to lose? $5. We would take 100 times our mathematical expectation would be -5. So we would expect to lose $5 after 100 times we played it. Okay? Which really is not that bad. No, that's actually pretty good. All right? You know, you're betting $1 over and over and over 100 times, and you can only expect to lose $5. Okay? Not so bad. Hey, that's probably a safe bet to make, right? Okay? Are you still losing money?
Yeah.
Yes. Okay? Now, if you are losing money as the player, what does that mean for the house? They're making the money. So you are losing 5 cents each time you play, but the house is gaining 5 cents every time somebody makes this bet on average. All right, let's get another one. Any questions before I erase all this? Okay. Okay, go ahead and read through example 2. Okay, so we have envelopes, right? And we get to just pick an envelope. And if the envelope has the money in it, we get to keep it. Okay? What's our sample space? We have envelopes with $1. We have envelopes with $5. We have envelopes with $10 and envelopes with $20. How many envelopes are there total? There are 10 envelopes total. Okay? Now, is there more than one way to win? Yes. And we'll break that up in a little bit, but overall, what's the probability of winning something? You are paying $5.
Would it be 2 out of 10?
It would be 2 out of 10, wouldn't it? The only time you're actually going to win money is if you get a $10 bill envelope or a $20 bill envelope, right? Okay. What about the probability of losing? 6/10. Why is it 6/10, Nathan?
So breaking even if you get one of 5.
Okay. If you get one of the 2 envelopes with $5, you're breaking even. So you're not winning or losing. Okay. What color? Well. Okay. So let's create our probability distribution. So we have the value and the expectation. Or, excuse me, the probability. I don't even know what I'm saying. Okay. So let's talk about each case separately. We are betting $5. What's the probability we get an envelope with $1 in it? 6 out of 10. And how much are we losing? We are losing $4 because we pay $5 and get 1 back. Okay. The next envelope, a $5 envelope. What's that probability? 2 out of 10. And what is the value there? 0. We pay $5, we get $5. We break even. You still have to include it in your probability distribution. Okay? How about getting a $10 bill envelope? What's that probability? 1/10, and we gain $5. Okay, and then there's a 1/10 chance we get the $20 envelope, and how much are we gaining there? 10. What? 15. Okay. Notice how here, yes, there's a probability 2 out of 10 of winning, but we have to separate it out because we have 2 different tiers of winning, if you will. Okay, we have you could gain $5 or you could gain $15, so we have to separate those out. So now for our mathematical expectation, okay, we can take -$4 times 6/10 plus $0 times 2/10 plus +$5 times 1/10 and +$15 times 1/10. Help me out. What is our mathematical expectation? -0.4. So each time you play this game, you can expect to lose 40 cents. Okay? Now, obviously after one time playing, it's not possible to lose 40 cents, okay? But over a period of time, you can expect each time you play to lose 40 cents. So if you play this game 100 times, we can take our mathematical expectation times 100. What do we get? Okay, negative $40. So if you play this game 100 times, you can expect to lose $40. Okay, so you go up to this game and you see, hey, no matter what I do, I get to win something. No, not really. Okay, you get something, but it doesn't, okay, you're still going to lose money in the long run. Okay, now, if our mathematical expectation for the player is negative 40 cents, what's the mathematical expectation for the house? Positive 40 cents. So if somebody plays the game 100 times, then the house can expect to make $40. You guys maybe see where this is going with our project here? Okay, you're going to create a game, all right, that we're going to use Tootsie Rolls as our wagers, okay? And you're gonna figure out the probabilities of winning, losing. You're gonna figure out the mathematical expectation, and then we're gonna actually play these games. And you're gonna use your mathematical expectation to compare how many Tootsie Rolls you actually made or lost off of your game. Okay? When you create your game, you have to ask yourself, do I want to make Tootsie Rolls off of the deal? Okay? Or do you want to lose Tootsie Rolls off of the deal? Right? So, your homework is the other side of this piece of paper. Now, you cannot squeeze your work onto this piece of paper. You're going to have to do this on a notebook paper. But there are 5 games. For each game, go through one at a time. You are going to have to do exactly what we just did. What's the sample space? What's the probability of winning, the probability of losing? Create your probability distribution. Find your mathematical expectation, and then how much you would win or lose after 100 times. Okay? After you do that for each game, there are some questions, 7 through 10, that I want you to reflect on. Okay? Which games are fair, which ones are not. Now, when I say fair, what would it mean to be a fair game? What would that mean?
You lose nothing.
Okay, if you come out with a mathematical expectation of 0, it's fair. You don't win, you don't lose. The house doesn't win, doesn't lose in the long run. Okay, that would be a fair game. You have an equal shot of, now the probability of winning versus losing may not be equal, but over the long run, okay, you're not expected to lose any money or gain any money or Tootsie Rolls or whatever you're wagering. Okay. So, you have the next 17 minutes to get started on this. Let's get to it.